So what we did before was in the previous lesson is that we looked at ionic bonding and we talked about how to write the formula if you know the charge of the metal. And so you know the charge of the metal if it is a group 1 metal, then it has a +1 charge. If it's a group 2 metal, then it's +2. If it's group 3, it's +3. And then you have two exceptions, which include zinc, which will always have a 2+ charge, and silver, which will always be 1+. But for all other metals that are transition metals, we don't know the charge of the metal. And so in order to deal with that, we have to include the charge in the name itself. Okay, so let's look at an example. If I gave you Cu2S, if I wanted to name this, I would name this copper sulfide, and that wouldn't be anything new. The problem is I don't know the charge of copper, so I've got to include it as a Roman numeral in between here in parentheses. So my hardest task for these problems is figuring out the charge. So here's the trick that I use. I uncross my charges. So I say, all right, this 2 came from the charge of sulfur, which was 2-. And so I check the periodic table and I say, yes, indeed, the charge of sulfur is 2-, so I'm good. The subscript for sulfur is an implied 1 right there, which means that the charge of copper is 1. And so I include that as the charge, and I am done with this. Okay, so keeping in mind as far as charges are concerned, Roman numeral 1 is +1, 2 +2, 3, IV is 4, V is 5, and 6 is VI. Okay, so let's look at another example. Okay, what if I give you, for example, AuSO4? Let's do a challenging one. Okay, so Au is gold, SO4 is sulfate. Okay, since gold is a transition metal and I don't know its charge, I'm going to need to include it here. Okay, so let's figure out the charge of gold. So since there is a 1 here, okay, what that is saying, because I didn't write anything here, that means the charge of sulfate I'm saying is 1-. And my question is it? Well, if you look, the charge of sulfate isn't 1-, it is actually 2-. Okay, which means there should have originally been a 2 here. Which means since there isn't a 2 here and there isn't a 2 here, that means that this should have originally been a 2. And what happened is that these were reduced. So that's a 1 and a 1. Okay, so since there was a 1 here, but the charge of sulfate isn't 1-, it's 2-, the 2 is going to go there. Okay, that means that since there isn't a 2 anymore, then it had to be simplified earlier on, which means there used to be a 2 here for sulfate, which means that the charge for gold used to be, or it is 2+, since there used to be a 2 there before it was reduced. So the charge of gold is now going to be 2. Okay, let's look at another problem. Let's say, for example, I give you Fe, let's do an easier one, 3PO4, 2. Okay, so let's check this. This is going to be iron phosphate, but because iron is a transition metal, I don't know its charge, so I got to figure that out. So if we look at this, I'm uncrossing my charges, so the 3 came from phosphate. Does that match up, or do I need to change this number? Well, the charge of phosphate is 3-, so I'm good, which means that the charge of iron is 2. Okay, let's look at another one. Just do a bunch of them to make sure we got them. I'm going to do iron again. I'm going to do Fe. Fe. Let's do FePO4. Let's do that. Okay, so again, I've got iron phosphate. Okay, but I'm changing the charge of iron here, so let's figure out what it would be. Since I didn't write any subscripts, okay, what I'm saying is that the charge of phosphate is 1. But the charge of phosphate isn't 1. It's actually 3-, which means this should have been a 3. So since this is a 1 and this is a 1, that means this should have been a 3 so that they could have reduced, which means the charge of iron is going to be 3+. Let's look at another one. What if I give you, for example, PbO2? Okay, so this is going to be lead. Lead is a transition metal, so I don't know its charge, so I'm going to have to include it. Lead oxide. Okay, let's figure out charges. So based on what I wrote here, I'm saying that the charge of oxygen is 1 minus, okay? Because when I cross charges, the 1 goes here. Well, the charge of oxygen isn't 1, in fact, it's actually 2 minus. So this should have been a 2, and this, since that was a 1 and a 2, this should be a 2, and this should have been a 4. So then the charge of lead is going to be 4 plus. Okay? Now, the good news is that writing the formula from the name is really easy. So for example, if I give you gold 2 sulfate, all you have to do is you would write Au with a 2 plus charge, sulfate with a 2 minus charge, cross your charges, that would become Au2 SO4 parentheses 2, because remember SO4 has to stay together, so I need a parentheses to have 2 sulfates. Okay? But then since I have a 2 and a 2, this would simply simplify to AuSO4. So when you're writing the formula from the name, it's really easy because in fact I'm giving you the charge of the metal, okay? And then you just cross charges. The challenging part as far as these guys are concerned is figuring out the charge. So go back and rewatch this video, and then we're going to do a lot of practice in class as well.